Okay, thanks for everybody for joining us. We're Vital Energy. We're going to talk to you a bit today about innovative approaches to net zero. There's a few things to run through. A bit of introductions about who we are, a bit about Vital Energy, and the sort of projects that we're working with. Cameron's going to talk to you a bit about the innovation, or one of the innovations that we're working on at Vital, which is the digital twin. And then we'll just summarise it and take any questions after that. So I'm John Williams. I'm a project development engineer for Vital Energy. So I work developing decarbonisation projects for NHS, public sector bodies, and very much focusing on today's technology, your heat pumps, your heat networks, chillers, secondary side modifications, the energy efficiencies of building fabric and things like that. Cameron works on our future technologies side of the business. So he works with a team that are looking at what's next and what can next. What are the tools that we can use in our decarbonisation projects moving forward? So Cameron, Dr. Cameron, I might add, did his PhD in controls and optimisation of buildings. So since joining Vital, Cameron's been working on our digital twin offering. So digital twin is something that Vital and many others have been using as part of their solutions for quite a few years now. But Cameron is refining that and taking it to the next level to bring additional benefits to trusts. Obviously we recognise that decarbonisation is an expensive business and grant funding through PSDS has obviously gone away. So we're now trying to look at ways that we can make these schemes affordable for NHS trusts. So a little bit about us. We operate in a wide range of sectors. We've got a self-delivery model, so we work with like district heating schemes. In fact, we build energy centres. So just outside here, I don't know if you're aware or not, but there's the energy centre next door, which is Vital's energy centre for the civic quarter. We've got a district heating network which is powering heat and power to this building as we speak, and numerous buildings in and around the city centre, and the Christmas markets this year will be powered from that energy centre as well, so just a bit of a fact there. But yeah, we're integrating all these sort of technologies, the heat pumps, solar PV, batteries and thermal storage. These are the sort of things that we're trying to already implement into our schemes. Every time we try and put one together, and then the services, obviously, decarbonisation plans. We take that through to design stage. So we have a team of designers at Vital that will do all the individual design elements and pull the scheme together. And then we have a project delivery team, the construction teams, and then through into operational maintenance after that. So we've got over 760 employees, so quite a big company. We're still growing. At the minute we've got 21 acute trusts that are already in that contract stage with the operational stage of a PSDS scheme. So we've gone through that first bit of the process of decarbonisation, we're operating and maintaining them, and now we are looking to bring additional benefits to them trusts through the innovation that we're developing at Vital. So solar PV arrays, just some numbers about the sort of stuff we do, but that's the main one there. So we're currently in the process of delivering, or have delivered, PSDS schemes, decarbonisation schemes for 26 acute trusts, with a total of over £250 million worth of grant funding through the CEF and through ourselves. So what I'm trying to say is decarbonisation and sort of technologies that you hear every day is like our bread and butter. We do that day in, day out. And even though trusts have their own little nuances and the challenges of implementing them on a daily basis, so it's not an easy process, but it's what we do every day, and we're well versed in. But then we're looking behind the scenes of what comes next, and how we can progress that and bring additional benefit and savings to the trusts. So just a couple of examples of that, of what we do, what we've done previously. So these are two projects that we've already completed and are in that contract cycle. Northwick Park, if you're not sure if you're aware of it, but it's a large hospital in northwest London. That project saves that trust £1.9 million a year in energy and 2,500 tons of CO2 a year. So that is a good example of everything that you can try and include in a project. So it's got batteries, it's got 600 kilowatts of water source and air source heat pumps. There's connectivity into a district heat network, which is available there as well. We've done lighting upgrades, so everything that you could kind of envisage in a decarbonisation project, that's got it in. But as coupled with that, Norfolk Park is quite unique in the fact that a lot of trusts struggle for space and they've got space constraints on sites. The energy centre there, we built that inside, so they were building a multi-storey car park, and the bottom floor of that we took that space and used that as our energy centre, which freed up the space for the old energy centre to be demolished after the project. Bridlington Hospital, it's not a big hospital, but everybody at Vice is really proud of this project because I think it shows what can be done with decarbonisation. So this particular site, we've got 600 kilowatts of heat pumps, 750 kilowatt solar array, which you might be able to see at the back of the photograph there. And the solar is sized big enough that it can power the heat pump systems entirely, as well as providing additional power to the site. So on sunny days throughout the year, there are times when that hospital is 100% heated and powered from the sun, essentially, renewable sources. So it's a project that we're really proud of. It reduced the carbon emissions by 65% on that trust, just by doing what we did there. And then as the grid obviously decarbonises as well, them savings will be enhanced. So that's what we do on a daily basis. We build up these schemes, and basically what I'm trying to say, it's a journey. We always start off with, where we start off is never where we finish. So these contracts we've run for sort of like 15 to 20 years, and we try to bring, obviously, the technology 15 years ago isn't where it is today, so we always try to look for that innovation and bring that additional value to trust. So I'll just hand over to Cameron. Cameron will tell you a little bit about digital twins.
Hello, thank you for that. So, you might be wondering, what's the digital twin? Some of you might have heard, some of you might just know it as an architectural 3D model. So, what I'm going to talk to you about is what we see digital twin as within what we're doing. So it's a virtual model of a physical system. So we take the site data, sizings, so various sizes of heat pumps, CHPs, battery storage, site, physical building sizes, the second side modelling. We'll take all that data in and we'll produce and create a digital twin that uses that site data. And what we can do with that is then compare that with current site data, and it's calibrated to it. So we know that if we've got a heat pump performing in the physical world, we can model it in the virtual world, and then that can help us move forwards. And a complete digital twin in the future of what we're doing might have a continuous flow of live data between the site and our digital twins. And that way we can see live any discrepancies. So if you've got any issues with your sensors drifting out of line, we can sort of pick that up. So in Vital, how can we use digital twins? So we can use them to test different control methodologies. We can do system optimization. So with the control methodologies and system optimization, what that means is we can go down to the component level, which we do, and we use a piece of software called MATLAB Simulink and Simscape, if you've heard of it. What we can do is go in Simscape all the way down to the component level, model the working fluids of, say, in a heat pump, a refrigerant, test different refrigerant types, and then coming out to sort of site, system-wide sort of view, we can then model different control strategies, and that means we can change PID gains in the controllers, change all that, test that, and find the optimal solution for how to run the site. And we can even change the order. So we've got, say, heat pump and boilers and CHP working to produce LTHW. We can change the order and sequencing around to test different strategies before a site's developed. or test the current site and test if we want to, say, put a new heat pump on there, what's the sort of cost benefit to that. We can also do model-based design, which is going, like I said, to future sites. So say we've got a current site that we've modelled and we can test new equipment in that, and then on the back end of that, linking into the continuous flow data, we can do visualization and analytics, so we can produce the sort of graphical reports that you'd need for your site. We can do comparisons with the digital twin compared to the physical site and put them into our reports. So to give a sort of rough example, sort of leading on from what I've discussed, say we've got a current site with CHP, boilers, hot wells, and our loads. Just looking at the LTHW side, we can model each of these at its raw component level in Simscape. We can then take that Simscape model and turn it into sort of a Simulink model, which we can use all the maths, all the physics, all the really complicated nerdy stuff, and put that into a model that we can run quite fast, can do sort of year look ahead simulation. We can model down to sub 1 second, so the computation time exceeds into the future. So we're looking at 1 second, 1 minute sort of simulation times for a year with that. So we can take current site X and then they come along, we want this new system, can you find the best mix up and make up of different pieces of equipment to make our site run better, meet the new demands of the site, which is what we can do. So that's all on the sort of primary side, so the generation side, but then we can also look at the secondary side, looking at the loads and model the buildings like this. We can model them down to the individual radiator sizes, split it up into multiple zones and do sort of the multi-zone modelling, so we can make sure that we've got an accurate representation of the loads and not just hourly load site data. We can go down to the minute by minute and accurately depict it. So off the back of that, the digital twin outputs is the complete knowledge of the maths and physics, and we can change that. Say we've got a heat pump that we want to test different refrigeration fluid, different working fluid, different return temperatures, flow temperatures. We can model that right down to the core component levels and test out new and innovative solutions to test does it actually work, and then we can take that and plug it into a site and see if it's going to have any added value at all. And we can then look at the deep levels of optimization, so that's going to a site with control strategy X and systems X, Y, Z. We can take that and optimize it and change it and make it better and work better on current sites without any hard labour or massive costs associated with it. So just fine tune, tweak some parameters that on site testing would take maybe a week. You change value X and then you wait a couple of days to see if it has a good benefit, and then you've got to go back and change it again. We can do that all within a day online on the component level if we've got a calibrated digital twin to go along with it. And that can obviously deliver enhanced control of the current systems and financial and carbon savings, and then moving forward with sort of longer energy performance contracts, we can update and evolve that digital twin alongside the evolving nature of a hospital site or whatever you've got. If you've got high-rise tower blocks, we can model that and evolve with it. If you've got a sort of 15-year contract, make sure that we're modelling it correctly, and that, say, like I come back to the sensors, if we've got sensor drift or sensor goes faulty, we can pick that up pretty quickly and do the sort of data to site data comparison. So thank you for that. I'll pass back to you.
Thanks, Cameron. So, just to summarise, really, so I think from what what this benefit brings, obviously, we recognise that decarbonisation is a financial strain on trusts, especially without PSDS funding. So anything that we do moving forward, we've got to try and make a positive business case for the trust. So the innovation that we're bringing behind the scenes with regards to the digital twin modelling there. So again, brings our models are more accurate through this kind of digital twin that we're bringing to the table. Like say down to that component level, it just means that everything gets more accurate. We can really refine and tweak and get the best efficiencies right out of every system. And that obviously gives the financial benefits to the trust. So couple that with the other things that we've got in the pipeline with Vital. So we've partnered with the University of Birmingham on phase change materials for thermal storage, smart metering, how to better use batteries and thermal stores and that sort of thing. We've got all these things behind the scenes that we're working on to try and give trust that positive business case. So get these projects off the ground essentially, so they're self-funding rather than trying to rely on government grants and things like that. So we're trying to bring all these out. If anybody wants to talk to us about either the digital twin or any of the other initiatives that we've got going forward and how we might be able to help trusts on the journey to net zero, then by all means give us a shout. Me and Cameron will be hanging around, we can answer any questions, or if you've got any questions now, then obviously we're happy to answer them as well. Thank you. More questions?
Yeah, so the example was Sorry. So yeah, I've got a power side model for one of the hospital sites I'm looking at the moment. It's a simplistic model in its current form at the moment. I've only been with Vital sort of 11 months trying to get holistic power and heat. So when we go further into the depths of the electrical model, we'll be able to model, like we were talking earlier about harmonics, we can model all of that sort of on site. We're not doing it yet, but we can do it. And that power model at the moment, I'm running at 1 minute time steps over a year, and it's taken sort of 10 seconds to run. So testing different strategies and different methods super fast.
I think that goes, just touching what we're saying as well, Dave mentioned, kind of eliminates the risk to the trust as well a little bit. So we were talking obviously about when we're putting these schemes together, if you're putting a massive heat pump on the grid, we have to do like harmonic studies and your G99 applications and things like that with the DNO. So I think it's part of what Cameron's looking to bring to the table as well, kind of eliminates that or reduces that risk really as well at that early stage of the project. Thanks. Yeah. Yeah. Yeah.
How's it going?
He's delivering, to be fair. I mean, to be fair, that site was when CHP was still a sustainable option. So that there's a CHP within that model. But as part of the strategy, obviously we've got a switch off date, so the trust can still hit the carbon targets as well. So, but that's offset against all the other measures that we've got going on site anyway. So it's generating financial benefit to the trust, but obviously we've got all the other benefits as well that contribute, that are offsetting the carbon intensity of that CHP. When that scheme first started and took off the ground, like I say, CHP was still very much part of these decarbonisation projects, whereas now I don't think we've put one in Vital for quite a number of years now, to be honest. That might have been the last one that we put in, to be fair.